Today the goal is to get you feeling more comfortable solving equations with fractions. We have three different types of equations that we'll look at, so we'll take one at a time and look at the different methods of solving them. First, we'll take a look at solving equations with fractional coefficients, and this should be pretty straightforward because we've already done it. If you take a look at example 1, it says solve each equation, and the first example, A, has negative 3/4 x minus 1 equals 2. And so just like with our previous equation solving, I'm going to go ahead and rewrite this with addition of a negative 1 equals 2. You guys can leave it as subtracting 1. The goal though is to see that you can add 1 to both sides in order to get the variable term alone. And if I add 1 to both sides, I get that the negative 1 and positive 1 cancel out. I'm left with negative 3/4 x on the left hand side equals 2 plus 1, which is 3. And then if you recall from our previous equation solving, we need to eliminate the negative 3/4 to completely isolate the x. And so we can multiply both sides by the reciprocal, which is negative 4/3. You guys can write it 4/-3 or put the negative out front. The goal is to understand that we do need to multiply by that negative 4/3 overall. And so I'm going to include an extra step right here where I'm going to show exactly what I get when I multiply across. If I do negative 4 times negative 3, I get 12. 3 times 4 in the denominator equals 12. X, and that's equal to 3 times negative 4 is negative 12. 1 times 3 is 3. And so simplifying completely, I get x, 1x equals negative 12 divided by 3, which is negative 4. And so I will not require that you plug these back in to do the test, but if you want to do a quick calculator check, you'll see that negative 4 does work in making the left-hand side of the equation equal to 2. Go ahead and solve the example in part B. I'd recommend that you pause the video, try it on your own, and then resume the video to see if you've solved it correctly before we switch it up a little bit by including more fractions. Unlike the previous example, we don't have to rewrite with addition. We do need to think about how do we get rid of the plus 4, so we can go ahead and subtract 4 from both sides, or it's the same as adding negative 4, whatever feels more comfortable for you. And so we're left with 2/3x on the left-hand side, and negative 2 and negative 4 make negative 6. To eliminate the fractional coefficient, we're going to go ahead and multiply by the reciprocal, 3/2. Instead of showing the step, I'm just going to talk through it. We get 3 times 2 in the numerator is 6, 2 times 3 in the denominator is 6, 6/6 is 1x, which was the whole point of multiplying by the reciprocal. And then if we do the same on the left-hand side, we get negative 6 times 3 is negative 18, 1 times 2 is 2, so x equals negative 9. Again, no check, but if we plug this in, it will work. Now we'll look at solving equations by rewriting each term with a common denominator, and this will occur when we have more than one fraction in the equation, specifically not attached to the variable. And so we have this first equation, 1/3 x minus 1 equals 5/6. First step I recommend is to look for the least common multiple. And so if we look at the denominators of each term, we have a 3 in the first one, technically 1/1, so we have a 1, and we have a 6. The smallest number that 3, 1, and 6 go into is 6. And so now we will rewrite each term using the LCM and equivalent fractions. Looking at the first term, we have 1/3 x. To get the denominator of 6, we're going to go ahead and multiply the 3 by 2. To maintain equivalent fractions, we'll also multiply the numerator by 2. And so we get 2 times 1 is 2 over 2 times 3 is 6, x. Looking at the second term, we have 1/1, and so to multiply to 6, we need to multiply by 6, both numerator and denominator, and we get 1 times 6 is 6, and 1 times 6 is 6. And we're setting that equal to 5/6, which we don't need to do anything to that fraction as it already has the common denominator. And then from here, it's solving a two-step equation, so the toughest part is done. You may want to rewrite with a negative 6/6, and then to eliminate that fraction, we would add 6/6 to both sides. The only term we're left with on the left-hand side is 2/6x, and that's equal to 5/6 plus 6/6 is 11/6. Last but not least, we need to multiply by the reciprocal to eliminate that fractional coefficient, and so we multiply by 6/2 on the left-hand side, and what we do to one side, we'll do to the other. So I'll show this extra step 6 times 2 is 12, over 2 times 6 is 12, x, and that's equal to 11 times 6 is 66, over 6 times 2 is 12. And we need to simplify that, so 12 over 12 is 1x, or x. And then if you see, the biggest number we can take out of both 66 and 12 is 6. And we are left with 11 over 2, or 5.5. We can also solve fractional equations with a method called clearing the fraction, where we eliminate the fraction in each term. And so we'll approach this the same way we did the last problem, where we're going to first identify the LCM. Since we're using the same equation, we know very quickly the LCM is 6. From here, what you're going to do is, instead of rewriting each term with the common denominator, you're going to multiply each term by the common denominator. And this will eliminate the fraction in each term. So I'm going to go ahead and rewrite the equation so we can more clearly see this happening. And I am going to rewrite with a -1 equals 5 over 6. And so I'm going to multiply each term by the LCM, which is 6. So I'm going to multiply by 6 over 1 to the first term, 6 over 1 to the second term, and then last but not least 6 over 1 to that third term. And so here I'm going to show this extra step. If you want to, you can as well. I get 6 times 1 in the first term is 6, over 1 times 3 is 3x, plus, in the second term here I have -1 over 1, so -1 times 6 is -6, over 1 times 1 is 1, equals 5 times 6, which is 30, over 6 times 1, which is 6. I'm going to go ahead and simplify. 6 divided by 3 is 2x, plus -6 divided by 1 is -6, equals 30 divided by 6, which is 5. And if you've noticed, multiplying by that least common multiple, that number that every denominator goes into, gets rid of the fraction. I have now a nice looking equation with just whole or integer numbers. And so from here, it's solving a two-step. I'm going to add 6 to both sides. I'm left with 2x equals 11. Dividing both sides by 2 to isolate the x term completely, I get, hopefully no surprise, x equals 11 over 2, or 5.5. And so I've used two different approaches to come to the same answer. While I'd like for you to be proficient in both approaches, you'll ultimately be able to choose whichever approach you feel most comfortable in using. Let's go ahead and take a look at one more example using both methods. Looking at this equation, we have -7/12 plus 2y equals 1/6. Let's go ahead and identify the LCM. Looking at the denominators here, I have 12, 1, and 6. The least common multiple, or smallest number that each of those numbers goes into, is 12. And so from here, I'm going to go ahead and rewrite each term with a denominator of 12. The first term stays as is. It has that denominator of 12. To multiply 1 to get 12, we're going to multiply by 12 and do the same to the numerator so that we maintain equivalent fractions. 2 times 12 is 24. 1 times 12 is 12, and we get y. Equals, to multiply 6 to 12, we're going to multiply by 2 and do the same to the numerator to keep equivalent fractions. 1 times 2 is 2, and 6 times 2 is 12. From here, it's solving a two-step. We want to isolate that y term, so we're going to go ahead and add 7/12 to both sides to cancel out that -7/12. We are left with 24 over 12y, and that is equal to 2 plus 7, which is 9 over 12. Our last step is to completely isolate the y by multiplying both sides by the reciprocal of the coefficient, which is 12 over 24. Instead of multiplying straight across the fractions, I'm going to look for common factors in both the numerator and denominator. And if you see, we have a 24 in the denominator and a 24 in the numerator. Well, 24 over 24 is 1. Same thing with the 12. We have a 12 in the numerator and denominator. That's just going to give me 1y, which was the whole point of multiplying by the reciprocal. If I take a look at the right-hand side of the equation, I see a 12 in the denominator and a 12 in the numerator. The 12 over 12 will cancel out to 1, leaving me with 9 over 24. This is a much easier fraction to simplify. I see the greatest common factor is 3. I get y equals then 3 over 8. Let's go ahead and try to solve this equation by clearing the fraction. If I take a look at the same equation, I have an LCM of 12. I am going to multiply each term now by that 12 to eliminate the denominator. So I'm going to rewrite the equation so you can see this more clearly. I'm going to show I'm multiplying by 12 over 1, multiplying by 12 or 12 over 1 with that last term as well. Looking at this first one, I have a 12 in the numerator, 12 in the denominator. 12 over 12 will simplify to 1, so I'll just be left with -7. If I look at the second term, I get 2y times 12 is 24y. If I look at the last term, I get 12 times 1 is 12, over 6 times 1 is 6, 12 over 6 is 2. From here, it's just solving a two-step. I'm going to isolate the 24y by adding 7 to both sides. I'm left with 24y equals 2 plus 7 is 9. Dividing by 24 is my last step to completely isolate the y. And from the previous problem, we know that we can divide 3 out of both the numerator and denominator, and y equals 3 over 8, and again, the solution matches on both sides. Now you'll complete some independent practice with each of these 3 example types.